Greetings. This is Nate's rendition of Homework Assignment 8, Problem 2, where a Poisson stochastic process with parameter lambda such that we're seeking the probability that n, the number of points arriving in the interval t1 to t2, equal k. And that probability is equal to e to the minus lambda t to the k over the k factorial. Another defined stochastic process is x to the t, where the value of 1 represents the odd number of points received in the previous stochastic process, and minus 1 represents the even number of points reached. Given that stipulation, we are asked to find the probability that xt has a value of 1. Okay, basically, this breaks down into the summation from k to 0, for k equal to 0, of lambda t to the k over the k factorial is equal to e to the lambda t. Now, in evaluating or determining a value for e to the lambda t, utilizing the Taylor series expansion, it comes out to 1 plus lambda t plus the quantity lambda t squared over the 2 factorial, and that series on infinitum. Then we come up with with e to the minus lambda t, and that's equal to 1 minus lambda t plus the lambda t squared over the 2 factorial. But in this expansion, we're going to negate the odd items. So it will be the quantity lambda t cubed over the 3 factorial, but then plus lambda t to the fourth power over 4 factorial, and so forth and so on. Now, we will then subtract from e to the lambda t, e to the minus lambda t, affecting a situation where we will actually end up removing the even points from the first assessment of e to the lambda t, and this will yield this 2 times the quantity lambda t plus lambda t cubed over the 3 factorial plus all the other odd points. And that subsequently, that summarizes to the quantity 1 minus e to the minus 2 lambda t divided by 2. Consequently, to get the value of probability of x of t to the 1, it does indeed equal the quantity 1 minus e to the minus 2 lambda t divided by 2. Part 2, or B, requires that we find the expected value of lambda t. Here, as opposed to what we did in the first part, we're going to add e to the lambda t plus e to the minus lambda t. This maneuver will do the complete opposite that occurred in the first part, where we will separate out all of the even points. So that comes to 2 times the quantity 1 plus the quantity lambda t over the 2 factorial plus quantity lambda t over the 4 factorial on out to the end, where we summarize by saying that the quantity is equal to the quantity 1 plus e to the minus 2 lambda t divided by 2. When we equate the probability of the quantity x to the t equal to a minus 1, it will indeed represent all of the even points and is equal to the quantity 1 plus e to the minus 2 lambda t divided by 2. The expected value, therefore, is equal to this plus 1 times the probability of of x to the t equal to 1 plus the probability of x to the t equal to a minus 1. In this case, it's multiplied by minus 1. I neglected to mention earlier that the first one was multiplied by plus 1. And when we substitute the probability factors, we end up with 1/2 times which would mean the value of the probability for the odd minus the value of the even points there in probability, which come out and summarize to a minus e to the minus 2 lambda t. Sorry for the stumbling through there. Thank you. Okay, continuing with problem 2, the homework assignment 8, section C, question C, we are charged to find the correlation of T1 and T2, as we can observe from the railroad telegraph diagram. Okay, there are only two possible values that we can achieve here. Is either a plus 1 or a minus 1, depending on where you are on the curve. You will either end up with plus 1 twice, okay, for T1, T2, or negative. Could be here negative, or up here it's positive. If you look down the line, where the product of the multiplication, or where you are at a particular point in time, you're either going to be plus 1 minus 1 or minus 1 plus 1. So we carry that forward in the computation for the autocorrelation. Like when we see we have x of t1 times x of t2, and the way that lays out on this first degree probability mass computation, we'll end up with plus 1 times the probability of x1 t1 times x1 t2, which equals 1, plus we'll have a minus 1, since we picked that factor, times the probability of x at t1 times x of t2 equal to a minus 1. And as we continue with the simplification of the equation, we'll end up with the probability of x t1 times x t2 equal to 1 minus the probability of x t1 times x t2 equal to a minus 1. And as we substitute in the values for the positive and negative probabilities, we'll end up with 1 plus minus 2 lambda to the t2 minus t1, the quantity divided by 2, etc. When we when we simplify those two, we'll end up with e to the minus 2 lambda, the quantity t2 minus t1. Thank you. The last section of assignment 8, problem 2, deals with whether or not the stochastic process x of t is WSS. And the answer is no, because the mean is not a constant. The expected value, or the mean, was defined in part B, where we have n of t equal to the expected value of x of t, which ends up equaling minus e to the minus 2 lambda t. Excuse me. And of course, noting that t is equal to t2 minus t1. Okay, thank you very much. Goodbye.